select star from account, and I really don't know why. So basically find all accounts at branches with LE somewhere in the name. So find me all accounts where the branches have some two-letter comparison of LE. So essentially what we want is some substring matching where LE is there somewhere. So we can use regular expression type equations or expressions in our code. That is select star from account where branch name like, and basically within single quotes percentage LE percentage single quotes. That means that percentages are basically used as pattern matching where it can match to any part of the string of any length. Underscore will basically match a single character. So basically now I don't know why you would do this, but essentially you would get something like this. So this account that has Seattle, that has an LE here, and Los Angeles as well because it has LEC, right? So that is how you would select branch names for a particular name. Okay. Now comes the from clause. Now the from clause is similar, basically the same as our Cartesian product. If you remember Cartesian product, let's see. I don't have an example here, but if you remember Cartesian product, remember that if we did, and what did we have? Loan and borrow. So if we combine these two tables, loan and borrower, using a Cartesian product, remember that we are going to get all possible combinations across all of those things, right? So when I say select star from borrower comma loan, it is going to give me the Cartesian product of borrower and loan. So customer name, loan ID, branch name, amount, right? Again, the same thing where loan IDs are different because most of these rows are not useful because the loan IDs and the loan IDs are different here. But if we do select star from borrower comma loan, we are essentially going to get a Cartesian product of two tables or more tables if that matters. Again, if we want to get relevant details from this Cartesian product, we would have done borrower.loan ID equals to loan.loan ID. Right? The same thing, table name dot attribute name can be used to distinguish between common attribute names, and select star from borrower comma loan. And when we say star, we mean all the attributes from borrower comma loan. So from the Cartesian product of borrower and loan, where borrower dot loan ID equals loan dot loan ID. Right? So that gives us the set of tuples that have the same loan IDs across the two tables. Can someone tell me what is this called?
Natural join.
Natural join, exactly, right? So in databases, it is also called an equijoin, right? So essentially, we will talk about natural joins and outer joins later, but for this, the set of fundamental queries that we have learned so far, we don't know how to do a natural join, or sorry, an outer join or a inner join yet, right? Left outer join, right outer join, and all of those things, and a natural join for that matter. So we don't need to do this like having a Cartesian product and things like that. There are operations for natural joins and things like that. We will talk about that later, next week. Okay. SQLs and joins, yeah, doesn't provide natural joins yet. If I remember correctly, and remind me later, but I believe that MySQL does not allow outer joins. It only allows inner joins and natural joins. But yeah, we will come to that later. Okay. Now, renaming tables. So remember that when we talked about renaming tables earlier in relational algebra, we can rename a particular table to another name. And also remember that we did this weird expression that found the maximum value in a table, right? The maximum amount in a table. And we did all of those weird things to actually get us the value. So find the loan amount that is the largest amount. By default, in general, a sane person would not do it something like what we did earlier, but essentially you can do the same thing as we did for that one. That is rename the table to another table that is from loan and loan as test. So that basically creates you the Cartesian product of loan with itself. Select distinct loan.loan ID where any loan amount is less than the test.amount. That gets you the list of all loan IDs that have some amount that are less than another amount. And then you can use that to get the max, but you would not use that. But essentially, we can rename tables in our query. But remember that this rename operation is valid just within this query. Right. After this query, this rename operation is gone. We are not assigning anything. We are just temporarily renaming our database or table. We can also use renaming operations to help us with long table names so that we don't have to write long table names everywhere, right? So we can say select c.custname, l.amount from customer as C, borrower as B, loan as L, where c.custname equals to b.custname and b.loan ID equals to loan. So essentially, it's a good idea to use rename operations using as to reduce your larger table names to smaller table names such that you don't have to write them again and again every time. One thing to keep in mind, and this is very important, is the order of all of these operations, right? So given select, from, and where, note that in select we are using C, but we don't know what C is yet, right? Because we are renaming C in the from operation. So remember this order, and this is important. In your databases, the from operation is always going to be executed first, followed by that the where operation is, where clause is executed, and then finally the select operation is executed, right? So first the from, then the where, and then the select. If you remember the corresponding versions, from was the Cartesian product, right? Where was the select, and select was the project, right? So if we look back to that particular version, yes. So first, if we had select from where, the Cartesian product happens first. So the from operation happens first, that is within the parenthesis. Then we do the where operation to select all the tables that we want using the predicate, the select all the relations. And then we project out using the select operation at the very end. So that is the order of operations that your database also executes your queries. Okay, set operations. So again, SQL gives you set operations, and we know of our set operations: union, intersect, and except. Except is essentially the set difference, union is set union, and intersect is set intersection, right? So if you want, remember for union operations or any of those set operations, the first thing that we need to remember is these are set operations. So if you're applying set operations on your queries, this is the only point in time where your database will consider those as sets and not multi-sets. So that means that they would duplicate, deduplicate, or remove duplicate your, remove the duplicate tuples in your table or your result. So if we want to perform a union operation between two sets of values, we can have one select operation that selects certain set of relations from a table, another select operation that selects another set of relations from another table maybe, and then perform union on it. So select one, union select two gets you the union of those two set of tuples. Same with intersection, select one, intersect, select two, and same with difference, select one, except select. And note that select 1 and 2 and all of those things, and you can have multiple unions as well, right? Select 1, union, select 2, union, select 3, union, select 4. And all of those are complete select statements. So what I mean with that is, let's say that we wanted to find customers with a loan and an account, right? So either a loan or an account, both of them would be fine as well. So we would say select customer name from depositor, union, select customer name from borrower, right? So that gets me all customer names, either who are depositors or who are borrowers, or both. Find customers that have an account but not a loan. Remember that was the difference operation. So select customer name from depositor, so have an account, except select customer name from borrower, who do not have a loan. We can also put in parentheses across our select operations, but just note that these are all complete select operations. combined together with our set operations, right? And we can add parentheses to our select operations for readability, but your database does not care when it's executing your query. Okay, any questions?
I have a question about the maximum and minimum one.
Mhm.
So, do you get to use the aggregate function, like the G thingy?
Yes, you do. Right in the next lecture.
Oh,
We'll
okay.
come to that. We will come to that in a second. But essentially, this was just an example for the renaming part of the thing.
So this is for like the relational algebra.
Yes, this is basically the corresponding thing that we did for the relational algebra thing.
Oh,
But
okay.
remember that even in relational algebra, we had aggregate functions, right? And here we did, this was just a roundabout way of getting to this particular max operation by just using the fundamental operations. But essentially we can do this. But remember that if we want, the one thing to remember, well, a couple of things to remember about renaming tables is that a table cannot be crossed with itself. So it has to be renamed to something else to be crossed with itself. And the second thing is we can just rename larger long table names to smaller table names.
Okay.
But remember, to where we need to rename it, we would always rename it in the from clause, because the from clause is the one that is going to be executed first.
Oh, okay.
Right? Any other questions?
For the
Yes.
last page, 37.
Yes.
After the renaming, C already changed into L. Oh no, C changed into B or C changed into L.
No, here we are renaming customer as C.
Yes.
So customer becomes C, borrower becomes B, loan becomes L. And then we can use it as C or L or B.
How about the table?
The
Table
table, well, these are different tables, right? Customer table, borrower table, and loan table. These are different three tables. So we are
we
basically,
okay.
yeah,
We
yeah.
actually didn't change the table name, right?
We are renaming the table name temporarily for our query.
Okay.
So we have three tables: customer, borrower, and loan, and we are renaming those tables to C, B, and L.
Oh, okay. Gotcha.
And when we say customer, comma, borrower, comma, loan, that means it is the Cartesian product of all of those three tables, right?
Yeah.
So customer cross borrower cross loan, not the bow tie, the cross,
Mm.
right?
Thank
Bow
you.
tie was the natural join. Okay,
Thanks.
you're welcome. Any other questions?
So if you want the bow tie one, is select and uh the star from?
Yes, so if you want the bow tie one, we have natural join queries as well. But if you want to use what we have learned so far, we would do something like this. So select star from borrower cross loan, so borrower comma loan, where the attribute names, same attribute names have the same value, right? That was
Okay.
natural join, right? So where borrower dot loan ID equals loan dot loan ID.
Okay, I'm good now.
Any other questions, guys? No questions? So I would really want you guys to I will also upload